US naval might visits our shores, a projection of raw military power after prowling contested seas. Lieutenant Commander Craig Hamilton has been Australian liaison on board USS America for 18 months. Part aircraft carrier and part amphibious assault ship. Its decks bristle with Joint Strike Fighter jets.
60-foot walls of water smashing across the horizon, winds that would topple skyscrapers, and a flight deck pitching like a seesaw. Yet somehow, a U.S. Navy aircraft carrier keeps launching jets as if nothing is happening. How? These ships aren't just floating airports. They're engineered fortresses built to fight both the sea and the enemy. But speed alone isn't enough, and one mistake on the bridge could turn survival into disaster. So what hidden systems, human and mechanical, make the impossible look routine in the deadliest storms on Earth? Before we move on, I'd like to ask you a small favor. If you appreciate this content, please take a second to like this video and subscribe to the channel. Over 98% of you watch the videos without subscribing. It costs you nothing, but it makes a huge difference to us. So, did you click the subscribe button? Great. Thank you so much. Now back to the video. Imagine a steel city the size of a downtown district, moving across the ocean at 35 miles per hour. Its flat deck, longer than 3 football fields, cuts through pitch-black waters where waves rise higher than a 6-story building. Every second the ship stays on speed, fighter jets can launch and recover, radar coverage stays wide open, and the strike group behind it remains shielded. But if the machinery falters, if the bridge miscalculates, or if the massive ship drops even a few knots in the middle of a storm, that protection vanishes.
Getting on and off a ship is the definitive skill that sets naval aviators apart from all others. 1,000 feet to take off and land. On a carrier, they have just 300.
If you're not focused and you're not prepared, then you're not going to be doing this business for very long.
Survival depends on more than raw size and speed. It depends on perfect control in conditions designed to strip control away. A carrier must generate enough wind over its deck to let its aircraft launch, even when nature is throwing its own gales across the ocean. That's why these ships are built to cruise in the 30 to 35 mile per hour range. At those speeds, the crew can sustain air operations and maintain their patrol cycles no matter the weather. But storms change the equation. Carrying full speed into a cyclone means the ship's bulk doesn't just ride swells, it collides into them. Steel plates reverberate as if struck by hammers. Bulkheads strain under stress measured in thousands of tons. And every surge causes the ship to slam back down into troughs with the force of an earthquake.
To take off on such a short deck, pilots have to generate extra speed. A 60,000-pound aircraft from 0 to 150 miles per hour in just 2 seconds.
It's kind of like being shot out of a gun. It wakes you up, it gets your adrenaline going, and it's pretty exciting.
From the flight deck, the experience feels like standing on a roller coaster track, except this ride has no pause button. The deck tilts up and forward, then drops hard, over and over, with spray blasting higher than the island tower. Crews handling jet launches must keep their focus sharp with the deck shuddering under their boots as it vibrates with each impact. The ship itself feels alive, shifting and groaning, while the sailors aim to keep operations steady as though the surface beneath them wasn't moving at all.
In the seconds before touchdown, pilots have to make countless small changes to get the aircraft to line up perfectly with the deck. The flight deck. It doesn't stay still. It heaves and sways with the sea. Pilots rely on a system of arresting wires. Catching one is called a trap.
In the nerve center of the ship, the bridge, the scene is a balance of calm voices and frantic energy. The officer of the deck stands with binoculars ready, issuing precise orders without hesitation. The helmsman grips the wheel, making tiny steering corrections to angle the bow into approaching seas. A team of engineers monitors pressure gauges, turbines, and shaft RPMS, relaying updates with no margin for error. Their coordination must be instant. A delay of even a few moments could mean turning incorrectly into a swell, or allowing the bow to fall off course, forcing the ship into a broadside roll it cannot afford. One wrong order in that chaos can halt aircraft operations or even compromise navigation. The margin for failure is razor thin. If the ship slows below necessary speed, recovering aircraft becomes impossible. Patrol jets, often monitoring threats hundreds of miles away, would run out of fuel and have nowhere to land. Without those aircraft cycling on and off the deck, the strike group loses its eyes and ears. Surface ships positioned around the carrier in a wide circle suddenly become blind without air cover, and every submarine or enemy patrol aircraft nearby has a chance to exploit the gap. This is why the team on the bridge pushes relentlessly against the storm, never letting up throttle, never drifting off heading. Navigation crews add one more safeguard to this balance. Sophisticated GPS and radar systems provide constant updates, but storm conditions and enemy interference can disrupt electronic tools. In those moments, sailors trained in traditional navigation pull out sextants and star charts. Even in near blackout skies, they measure positions against what little visibility they have, ensuring the carrier holds its course through open ocean. Its ancient seamanship blended with nuclear-powered propulsion, creating layers of backup that prevent a storm or an enemy jammer from sending the vessel adrift. All of it proves that the real defense against nature's fury comes from movement and precision, not from how thick the steel hull is. The engines generate speed, the navigation team finds balance, and crews on the bridge make decisions in seconds that keep the entire city pointed where it needs to go. It takes mechanics, training, and an iron focus to keep 100,000 tons of warship charging through water that wants to stop it cold.
Is one of those wires. It feeds out the appropriate amount of cable to stop you before you would go off the end of the landing area.
But what you don't see is all the practice and repetition that goes into making that look that way.
But pushing forward at full speed and keeping discipline in chaos is only half the equation. None of it matters if the ship runs out of power. That leads to the bigger question: how can a moving city this massive keep driving through endless seas without ever stopping for fuel? A tsunami or storm does not sink a U.S. carrier because power, people, and design converge into one system. Nuclear reactors drive engines that never run out of fuel, while crews trained for chaos manage every detail under punishing conditions. Steel and bulkheads resist strain, but discipline ensures survival. These ships are not built only to endure. They remain operational while enduring, capable of launching jets in seas that would shut down any airfield. That ability projects control anywhere on Earth. So ask yourself, if nature cannot halt these fortresses, what signal do they send when they appear in contested waters?